So in the homework, some of the things you're going to see is it's going to ask you to. We're just going to take the first little bit over here. So forget about all the other stuff over here for a little bit. We're just going to worry about cosine and sine for just a second. If we're going to do cosine of pi over 3, again, all you have to do is you go to your unit circle, you find pi over 3, and cosine is the first number that's there. So if it asks you to find the cosine of pi over 3, it's going to be a half. All right. If they ask you to find the sine of pi over 3, you go to pi over 3. Tell me what the second order pair is, the y coordinate. That's square root of 3 over 2. Okay. And then, again, we're just going to work down the page. We're sine and cosine. We're going to come back and get the other operations over here in just a minute. We'll get there. So pi over 2, cosine is 0, sine is 1. So if you're asked to find the cosine and the sine, you're basically just giving me the ordered pair at that value at that location that we're working through. Pi over 6, square root of 3 over 2, and 1/2. Right. Pi over 4. What's a good thing about pi over 4? Same thing. Yeah, same thing twice, right? And if you notice on here, and this is one thing that hopefully you'll kind of start to notice on these, what do you notice about every number that ends with pi over 4? Yeah, it's always square root of 2 over 2, right? It just depends on the signs that some of them will be positive and some will be negative. So anytime you see pi over 4, you know that the answer is always going to be square root of 2 over 2. Square root of 2 over 2. It's just a matter of, if it's 3 pi over 4, the first one's negative. If it's 5 pi over 4, both of them are negative. If it's 7 pi over 4, then it's the second one's negative. But it's always going to be square root of 2 over 2. If you kind of notice the same thing with pi over 6s. Every time it's pi over 6, it's square root of 3 over 2. You've got 5 pi over 6, square root of 3 over 2. You've got 7 pi over 6, square root of 3 over 2. So anytime you go to a pi over 6, it's always going to be square root of 3 over 2 and 1/2. It's just a matter of which one's negative and which one's positive when it comes off of it. And same thing for, if you're doing a pi over 3. All right, so for pi, that's here. That's negative 1, 0. If we go now, change it in this case. Instead of doing radians, we're asking for degrees, but it's still the exact same thing. 330 degrees, that's square root of 3 over 2, and then negative 1/2. All right, so here's the one thing where it starts to change just a little bit. We've got a negative 45 degrees. All right, and what we said yesterday is that if the way this thing works is if you start at 0, it goes this way in a counterclockwise motion. So guess what happens if you have a negative number?
Clockwise.
Yeah, we're going to go clockwise, right? So now we're going to start here, and we're going to go down. And basically, if we're doing negative 45, all we're going to do is we're just going to take that number that's negative and just subtract it from 360. So if we've got a negative 45, that just means we've got to go down 45 degrees. So if we do 360 minus 45, that's 315. So that puts us right here at 315. So then if we're asked to do the cosine and sine of negative 45 degrees, that's basically the same thing as 315. So that's square root of 2 over 2, and then square root of 2 over 2, where the second one is a negative. Okay, so if it's a positive direction, that means you've got to go this way. If it's negative, then you're going to start here at basically 360, and then you're going to go that way. And again, the easy way to think about the negative numbers is that if you're going to start at 360, you're just going to do 360 minus that number, and then that'll tell you where you're going to be on here. All right, now, and then if it's in radians, if it's 7 pi over 6, a lot of times, especially, it's working through this one. And for me, the first time I did this, I always had to go back and think about it being degrees. It's because, again, we're only doing this for about a week and a half. Well, with all the days off, we're going to spread this out to about 2 weeks because we're out Friday, we're out Tuesday. So, it won't quite sink in. So a lot of these things you're going to look at and you're going to think, all right, what is that in terms of degrees? So if it was 7 pi over 6, 7 pi over 6 is 210. So if it's negative 7 pi over 6, that's really the same thing as like negative 210. We're doing degrees. So for that part of it, we're going to start at 360, and then we're going to subtract 210. And if we do that, that puts us at 150. So if it's negative 7 pi over 6, which is negative 210, if we go down 210 degrees, that would also put us back over here at 150 degrees. So now we're going to use this for our x and our y there. So that's negative square root of 3 over 2 and 1/2. Yeah. Everybody okay with the negatives? Okay. Oh, that if this was just 7 pi over 6, 7 pi over 6 is basically the same thing as 210. Yeah, so if it's negative, you just make it negative. Okay. What's that? Everybody all right with that one? Okay. All right, now what about 720? How would we get to 720 on the unit circle? Yeah, we'll go around the circle twice, correct? That if you go from here 360 degrees, it goes back to here. If it's bigger than 360, that just means you just keep on going. So if we keep going another 360, that will bring you back to here, which basically says if we go 360, we're here. If we go another 360, we're back to here. So 720, it's basically just multiples of 360 that you're just multiplying it by a number. So yeah, so that would put you right back here. That'll put you back at 10. Same thing if it asks for 540. Well, 360 would get you to here. If you've got to get to 540, if they gave you one where you had to do 540, once you get back to 360 and you subtract those numbers, that means you got to go 180 more degrees. So if 360 will get you to here, then you got to go 180. That would get you back to there. All right, and then the last one, which is probably the hardest one on here. 13 pi over 2. All right, you got a couple options you can do on this one. You can either leave it 13 pi over 2, or you could change it back into a mixed number. So if we change 13 pi over 2 back to a mixed number, okay, that'd be 6.5 pi. And that may not help, but we'll kind of see. And here's kind of the good thing, kind of spinning off that part of it we've got here. Wait, go back. Okay, we'll hold it. Okay. All right, so a couple of ways you can do this one. And we'll show you both of these. If it's 6.5 pi, here's kind of one thing you want to notice about the unit circle. If you start at 0 and we go 180 degrees, okay, that's 1 pi. You go another 180, that would be 2 pi. What happens if you go another 180? That'd be the third time you've used pi, right? So that would be 3 pi. If you go another 180, now you're at 4 pi. You go another 180, now you're at 5 pi. You go another 180, now you're at 6 pi. So if you just keep counting by pi's, every odd pi would be here. Every even pi would be here. So if it's 1 pi, 3 pi, 7 pi, 9 pi, 11 pi, 1,693 pi, if it's an odd pi, you're always going to stop here. If it's an even pi, you would stop here. Because it's just spinning around in a circle. Because that's your only options you get for this one. So if it was just 6 pi, we'd be back here, 10. But then we got to go a half pi more. And a half pi is the same thing as just pi over 2, right? So if we're here at 6 pi, go up pi over 2 more, that would put you right here. So now we're at 0, 1. Okay. Okay. Now here's another option you could do, and some people don't like this one as much, but we'll show it to you anyway. All right. Okay, this is 1 pi over 2. All right. If we get over here, this would be 2 pi over 2. but the 2's would cancel to make it just pi. Down here, we've got 3 pi over 2. This would be 4 pi over 2, but that cancels to get 2 pi. So if we keep going 90 degrees, you keep adding a pi over 2. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. This would be 5, 6, 7, 8, 9, 10, 11, 12, 13 would put you back there. So different way of thinking about it, but still kind of get you back to the same spot. Okay, now again, you don't have to worry about. There's not a lot of those, so most of them it's going to be just finding sine, cosine, tangent, that kind of thing, to get us there. All right, so here's the big thing. Here's the big part of today. This is where I need everybody kind of hanging in, because if I lose you here, then well, I may not get you back for today. So, all right, on the back of this thing, on the back of your pink sheet, here's what we're gonna do. And we mentioned this yesterday, but we said that tangent is going to be sine over cosine. Okay. All right, and there's 3 other new ones we got to throw in here. And again, we talked about this just a little bit yesterday. We'll throw these in. Secant. Now, there's a different secant in geometry where secant is a line that hits a circle in one spot. This is not the secant we're talking about here in this case. This is where we're talking about the trig operations. So secant for short is just SEC. Yeah. And secant is 1 over cosine. So if you know your cosine number, secant is just 1 over, it's the inverse of cosine. All right. If you do cosecant, the abbreviation for cosecant is CSC. And cosecant is the inverse of your sine, which is 1 over sine. Yeah, so you got secant, cosecant, and cotangent. Cotangent. All right. And cotangent, it's kind of easy. It's just COT. All right. And cotangent is 1 over tangent. But the easy way to remember cotangent is that if it's the opposite of tangent, if it's the inverse of tangent, you just flip this thing upside down. So it's going to be cosine over sine. Question. Go ahead, Charles. We don't have to worry about negatives in that case, because the negative is just instead of moving in the positive direction and adding it to 0, that basically negatives, you're just going to subtract it from 360. So it's basically the same thing. All right, so here's the big thing. On the front side, we're going to go back over here, and we're going to show you what tangent is based on these numbers. Again, tangent, we're going to go ahead and write on here that it's sine over cosine. Okay, and some of these will be really easy. Some of these we're going to go back and show you how to work these out on the back. So if they ask you to find the tangent of pi over 3, that whenever they ask you to find the tangent of some number, you got to realize that really it's just the sine of that number over the cosine of that number. Okay. But again, if you've got your unit circle, it's really easy, because you know that if you're doing the sine of pi over 3, that's just your second number, which is square root of 3 over 2. And you know that cosine is your first number, your first order pair coordinate. So it's 1/2. Okay. And does everybody remember your sixth grade math? Probably not, right? That we're going to simplify this, but we're going to do it on a separate piece of paper just because we're running out of room here. But if you have square root of 3 over 2 over 1/2, if you have to simplify that, we're going to. Yeah, there we go. Somebody said it. Yeah, you're right. Yep. Yeah. We're going to keep it. We're going to change it. And we're going to flip it, right? Okay. So if we keep it, change it, flip it, we've got square root of 3 over 2 times 2 over 1. The great thing about that is what happened to the 2's? They cancel each other out. They're gone. It's square root of 3 over 1, which is just square root of 3. There you go. All right. Is everybody okay with that one? Because again, if you got to do tangent of pi over 3, you just go to pi over 3. You give me the sine value on top. You give me the cosine value on bottom. And then you just simplify that fraction as much as you can. No. All right. So pi over 2. So tangent of pi over 2 is the sine of pi over 2, which is 1, over the cosine of pi over 2, which is 0. Now, again, you're going to have to do this. Here's the bad news. I guess, well, not necessarily bad news, but for this test, you cannot use the Casio calculators. You must use those calculators that are on the board, or another calculator that I verified that says it's okay. Because the Casios are too good in this case, you're going to have to use a calculator to my liking. Basically, what it comes down to. Casios are a no-go on this test. All right. Does anybody know what the answer to 1 over 0 is? Ah, yes. There we go. It is undefined. 0 on the bottom makes it undefined. 0 on the top, the answer would be 0. But in this case, it's undefined. All right, pi over 6. All right, so we need to change the pi over 6. So that is the sine of pi over 6 over the cosine of pi over 6. Okay, now here's what we need to do for this one. For this part, we'll go ahead and leave this, but again, we're going to go back to a separate piece of paper. If you actually want to flip over to the back of this one, we're going to show you how to do this one. So we got tangent of pi over 6. Tangent, yeah. All right, so we got tangent of pi over 6 is 1/2 over square root of 3 over 2. If we keep change flip here, we've got 1/2 times 2 over the square root of 3. And same thing again, the 2's cancel, correct? And you're left with 1 over the square root of 3. Okay, now that is possible, but here it is. The math snobs, as they are, say, well, it's improper if you leave the square root in the bottom, in the denominator. Yes, the math snobs do. So the math snobs say that if you have a square root in the denominator, you must rationalize the denominator. Okay, which is fancy for you've got to eliminate the square root from the denominator. All right. So we've gotten to here, and basically this is an answer, but this is a not good answer. Because again, the math snobs do not like that answer. All right. So if you're left with a square root in the denominator, you have to rationalize it. And we're going to show you the long way, but then we're going to show you the shortcut for this too. So to rationalize the denominator, to eliminate the square root from the denominator, you're going to do basically one thing. You're going to multiply the numerator and the denominator by the denominator's radical. Okay, so we've gotten to the point where we've got 1 over the square root of 3, which is, again, it's a good answer, but it's not going to, if you put that answer in, they're going to count it wrong. Okay, because the math snobs say that's not the right way to do it. So what we've got to do is we've got to get rid of this square root of 3 that's in the denominator. So if we take this answer that we've got here and they ask you to rationalize it, all you have to do is you're going to multiply the numerator and the denominator by whatever radical you have that's in the denominator. But you do not have to switch signs. That's correct. You're just multiplying by that number. So it's square root of 3 times the numerator and square root of 3 times the denominator. Okay, on the top part, it's 1 times the square root of 3, which is just square root of 3. All right, on the bottom, you've got 3 times 3, which is 9. So you've got square root of 3 over square root of 9, but what is the square root of 9? 3. So your final answer then would be square root of 3 over 3. All right. Now here's the shortcut. If you want the shortcut for this one, here's your shortcut. Because I mean, it's not terribly long, but here's your shortcut you can do. You just move the radical from the bottom to the top. So in this case, we took the square root of 3 we had here. We moved it from the bottom. Now we've got square root of 3 in the top. And then on the bottom, just remove the radical from the bottom. And that way you leave just the number. So you're going to move the square root of the number from the bottom to the top. So we took the square root of 3, moved it from the bottom to the top. And then on the bottom, you just take the square root off the bottom, and then you're good to go. Because every single time you do this one, if this had been square root of 5, you would wind up doing 5 times 5, which is 25. But when you square root 25, you're just going to get the 5 back. So it's always going to be that same kind of thing when you go through this one. So you just move the square root of the number from the bottom to the top. And then on the bottom, you just take the square root off and then just leave the number. Okay. So there's where we're showing our work for tangent of pi over 6. So if you want to go back on the front side now, and we started with this, if you want to just say we skipped all this and we finished up that the answer was square root of 3 over 3, we can leave that answer there. Okay, now some of these get to be kind of easy because if we do tangent of pi over 4, what happens when you do tangent of pi over 4? You get the same thing over itself. What happens when you put the same thing over itself? Oh, yeah, you just get 1. Look at there. Okay, if we do tangent of pi, that's 0 over negative 1. What happens when you put 0 on? Now, 0 on the bottom is undefined, correct? 0 on top is just 0. 0 on bottom makes it undefined. 0 on the top makes it just 0. All right, if we do tangent of 330. That is negative 1/2 over square root of 3 over 2. And you may go, oh, you mean I got to do all that work again? Absolutely not. Because you've already got this same answer here, correct? You've already got 1/2 over square root of 3 over 2. You've already know what this answer is. It's going to be square root of 3 over 3. So we know this answer would have to be the same thing. Okay, so what happens when you divide a negative by a positive? What kind of answer do you get? Just a negative. Yeah, so it's now square root of 3 over 3, but it's just negative square root of 3 over 3. So you don't have to recreate the wheel every single time you do these. That basically, I'm giving you a cheat sheet for all the answers. That anytime you set up tangent and you go, oh, it's 1/2 over square root of 3 over 2, I know the answer is going to have to be square root of 3 over 3. If we go to negative 45, we got to find the tangent of negative 45 degrees. We know that that's going to be sine over cosine, but we already know if you do square root of 2 over 2 over square root of 2 over 2, we know it's going to be 1. But we've only got one negative over here, so we divide a negative and a positive. That means the answer has to be a negative. There you go. All right, we've got tangent of negative 7 pi over 6. That's 1/2 over square root of 3 over 2. But if you look up here, oh, look, that's the same thing we had right there, right? So we know it's going to be square root of 3 over 3. We're dividing a positive and a negative. That means the answer is going to be a negative. So all the answers are there. You just have to realize, oh, if I set this up, then the answer always is going to be this. Or if I do this, the answer is always going to be that kind of thing. All right, we got one more here. If we do tangent, two more actually. Tangent of 720, that's 0 over 1. If 0 on top, the answer is
0.
0. Thank you. If we do tangent of 13 pi over 2, that's 1 over 0. That is, there we go, undefined. So the good news is if they ask you to find tangent, there's only 5 answers. It's either square root of 3 over 3, it's 0, it's undefined, it's 1 or negative 1, or it's possibly square root of 3. And that's the only answers you can possibly ever get for tangent of something on the unit circle. That is the only answers that's there. So when you're doing your homework tonight, you start looking at some of these. That's your only options. That's the only thing it possibly could be there. Okay. All right, now we're going to use that to kind of show you the last couple things because once we got those, yeah, then the other ones kind of do basically the same thing here. Because when we do sine, a secant, or cosecant, or cotangent, it's all basically set up to be kind of the same thing. It's just using different numbers when it comes off of it. Okay, so for secant, we said that secant was, we flip back over here in the back real quick. Secant is just 1 over cosine. So, Aja, you good now? Okay. So for secant, that's 1 over cosine. So if we have to do the secant of pi over 3, that's just 1 over the cosine, which is 1 over 1/2. And again, kind of running short on room in this one, so I'm going to go back to my scrap sheet here for a second. If it's 1 over 1/2, if we keep it, change it, and flip it, this one works out really nice because it's 1 times 2 over 1, which is just 1 times 2. So it's just a plain old 2. Okay, and just to save us some room here, I'm not going to write out what the secant for this part. So if we're doing secant of pi over 2, that's 1 over the cosine. Oh, sorry. It's 1 over the cosine. So that's 1 over 0. Oh, look, and we already got the answer right here. If that's 1 over 0, we know that's undefined. Okay. If we do secant of pi over 6, that is 1 over cosine, which is square root of 2 over 2. Okay. And then we got to do our... Oh, yes, my bad. Square root of 3 over 2. Thank you. All right. So we got 1 over square root of 3 over 2. Do we have 1 over square root of 3 over 2 here anywhere? No, we had a half over square root of 3 over 2, but we didn't have 1 over square root of 3 over 2. So we'll do that one real quick so we can see what we got. And again, we're going to go just over to the scrap sheet here if you want to go to the back, wherever you got it. So it's 1 over square root of 3 over 2. If you keep it, change it, and then flip it, we've got that. The good news is it's 1 times that one. So the 1 doesn't do anything. So that's really just 2 over the square root of 3. Okay. And we're going to go long route or short route to get the rationalized part here?
Short route.
Short route. Okay. So again, we're going to move the square root from the bottom to the top. The 2 is already there. So we move the square root of 3 from the bottom to the top. On the bottom, just leave off the square root. And there you go. Okay. So that's 2 square root of 3 over 3. Okay. If we do secant of pi over 4, that's 1 over cosine, which is still square root of 2 over 2. Okay. Again, if we go back over here just so we can check it real quick, that's 1 over square root of 2 over 2. Again, keep it, change it, flip it. That is 1 times 2 over the square root of 2. And again, we got 1 times it, so that doesn't do anything. That's just 2 over square root of 2. And then let's rationalize it. Again, we'll go shortcut. The 2 is good. We're going to move the square root of 2 from the bottom to the top. And on the bottom, we just leave the number. But what can we do? Yeah, cancel out these 2's, right? Because you got 2 square root of 2 over 2. Those 2's are cancel. So that one's just square root of 2. Okay, and everything else back here on all these other answers, when we do the rest of the secants, when we rest do the cosecants, we do all the cotangents. All these other answers are just going to be one of these answers that we already got here. So in this case, secant is negative, so we do the secant of pi, that's 1 over the cosine. What's 1 over negative 1? Look at that. How is that? Negative 1. This one is 1 over square root of 3 over 2. But guess what? You don't have to recreate the wheel because we've got that same answer right there. We know that answer is 2 square root of 3 over 3. So every answer after this is just going to be a repeat of one of these answers we got here. This is 1 over the square root of 2 over 2. We just did that one right here. We know that answer is going to be just square root of 2. So once we fill out this chart, again, you got a cheat sheet because every answer on here is every answer that possibly could show up for any of these things that we're going to do here. No matter what you do. So now we've kind of listed all the possibilities. So let's say if we're doing cosecant, which is 1 over sine. And let's say we were doing this pi over 6 right here. Just jumping to a random number here. So if we had to do the cosecant of pi over 6, cosecant is 1 over sine. That's 1 over a half. But we did that. Where did we do that? Oh, right here. Here's 1 over half right here. That answer was just 2. So once we've got these few set of numbers here, every answer here is going to be one of these answers we've already kind of done back here. Okay, and again, we're not going to do all of the rest of them because it's just going to be repeating these exact same things. And we may fill in the rest of them tomorrow as we're kind of going through that one. But everything else through here is just going to be repeating these answers that you've got. So once you've got this, you've got every possible answer you could ever look for in the homework. Okay. All right. So what we're going to do, I'm going to go ahead and stop this.